From a distance, this planet presents the illusion of familiarity. Soft blue hues, drifting clouds, and the quiet silhouette of a world we think we know. But as we analyze the atmosphere and approach the surface, the illusion turns violent. The air shreds with glass-sharp silicates, the rain cuts like razors, and nothing gentle survives for long. This is not a world suited for life as we know it. With temperatures soaring above 1,000 degrees, winds tearing at thousands of kilometers per hour, and a chemical brew of silicates suspended in its skies, survival here borders on the impossible. And yet astrobiology shifts the question, not from whether life is likely, but to something deeper. Could the laws of nature, when shaped by time, pressure, and chaos, produce a form of survival we've never imagined? One that does not resemble life on Earth, but something stranger, honed by violence, and utterly alien. Hey guys, thanks for joining me in this video. It means a lot. Let's get into it. Welcome to the first episode of our new series, Strange Planets and Possible Life, where we explore the cosmos' most alien worlds and ask, could anything survive there? HD 189733b wears the mask of home while harboring the fury of hell itself. It looks like Earth, this distant world, with its mesmerizing cobalt hue that speaks to something deep within our evolutionary memory. Yet step 1 foot onto its surface, and it will tear you apart, atom by atom, shred by shred, in a symphony of glass and fire that makes our most violent storms look like gentle summer rain. This is the Glass Storm Planet, where beauty and terror dance together in an eternal waltz of destruction, where the very air bleeds molten glass, and winds howl at speeds that would shame our mightiest hurricanes, where day burns with the fury of a forge, and night freezes with the emptiness of deep space. Here, in this corner of the cosmos, we find nature's most beautiful nightmare. Welcome to a world that challenges everything we thought we knew about planets, about extreme exoplanet weather systems, and about the delicate dance between beauty and destruction that plays out across the universe. This is HD 189733b, and in this video, we journey to hell disguised as heaven, 63 light years. In cosmic terms, this is practically next door, a neighbor whose light began its journey to us when humans were first learning to harness the power of radio waves. The constellation Vulpecula, the little fox, holds this secret in its stellar embrace, invisible to our naked eyes but blazing bright in the infrared spectrum, where our most sophisticated telescopes can pierce the veil of space and time. HD 189733b orbits a star much like our own sun, though slightly smaller, slightly cooler. Discovered in 2005 through the transit method, a technique now widely used in exoplanet detection, astronomers watched in fascination as this world passed in front of its parent star, creating a tiny but measurable dimming that betrayed its presence. Like a cosmic lighthouse sweeping its beam across the darkness, this planet revealed itself through shadow and light. NASA exoplanet discovery teams have since focused on HD 189733b, intrigued by its bizarre combination of proximity, vivid color, and violent weather. Scientists studying this exoplanet were stunned by the data pouring in. This planet shattered assumptions, but what they found defied expectation. This is a hot Jupiter, a class of gas giant exoplanets that has wandered far from where planets like it should exist. Larger than Jupiter itself, with a mass that could swallow our world whole, it orbits its star so closely that a single year lasts just over 2 Earth days. Imagine that, a world where seasons are measured in hours, where the dance between planet and star is so intimate, so intense, that it has locked them in an eternal embrace. This proximity breeds violence. The star's gravitational grip has seized HD 189733b in a tidal lock, forcing one hemisphere to stare forever into the blazing face of its sun, while the other turns away into perpetual darkness. This is a world split between extremes, between the furnace and the freeze, between the light that burns and the darkness that numbs. From Earth, through our most powerful telescopes, HD 189733b reveals its secrets in wavelengths of light that tell stories no human eye could ever see. We have measured its size, tracked its orbit, and even begun to taste its atmosphere. In the grand catalog of known exoplanets, thousands of worlds spinning around distant stars, this one stands apart, not just for its proximity, but for the sheer alien beauty of its deadly embrace. Why does a world of molten glass and screaming winds appear as blue as a summer sky? The answer lies in the very air that would kill you, in an atmosphere so alien, yet so familiar, that it challenges our understanding of what makes a world beautiful. HD 189733b's atmosphere is a cocktail of death served in Earth's most beloved color. The deep cobalt hue that makes this world so hauntingly familiar comes from silicate particles suspended in the air like microscopic diamonds. These are not the gentle water droplets that paint our sky blue through Rayleigh scattering, but rather tiny fragments of what would be glass and rock on terrestrial planets like ours. At temperatures exceeding 1,000 degrees Celsius, hot enough to melt copper, these silicates exist in a state unknown on Earth. They float in the superheated atmosphere as aerosols, each particle a microscopic mirror reflecting and scattering blue light while absorbing the reds and infrareds. It is as if the planet has filled its sky with powdered sapphire, creating a beauty so intense it seems almost artificial. But this is beauty born of violence. These silicate particles form in the scorching heat of the dayside, where temperatures rival those in a glass furnace. Here, in the eternal noon of this tidally locked world, the very molecules of rock and metal are torn apart and reassembled in the thick, crushing atmosphere. Sodium burns in brilliant yellow, magnesium glows like stellar fire. The air itself becomes a crucible where elements dance in forms that exist nowhere else in our solar system. The atmospheric pressure crushes down with a weight that would flatten any visitor long before the heat could cook them or the toxic chemistry could poison them. Yet, from space, from our safe distance of 63 light-years, all we see is that mesmerizing blue, that color that speaks to every human who has ever looked up at Earth's sky and felt the pull of home. This is the deception of distance, the lie that beauty tells across the cosmic void. HD 189733b wears its blue like a mask, hiding the violence beneath a facade that evolution has taught us to trust, to love, to associate with life itself. In this way, the universe reveals its capacity for the ultimate irony, clothing its most hostile worlds in the colors of paradise. Yo guys, keep watching as we reveal the most violent weather system ever recorded on an alien world. A system so intense that it continues to shock atmospheric scientists and astronomers alike. Appreciate your time and attention. Now we descend into the heart of the storm, into weather so violent it rewrites the very definition of what we call wind and rain. On HD 189733b, the forecast is always the same. Glass storms, with winds exceeding 7,000 kilometers per hour, temperatures that would vaporize lead, and atmospheric pressure that would crush a submarine. 7,000 kilometers per hour. Let that sink in for a moment. The fastest winds ever recorded on Earth barely reach 300 kilometers per hour before our most violent hurricanes exhaust themselves. But on HD 189733b, winds that would make a Category 5 hurricane look like a gentle breeze are the baseline, the calm before an even more terrifying storm. These supersonic winds are born from the planet's tidal locking and the enormous temperature differential between day and night. On the day side, temperatures soar above 1,000 degrees Celsius, heating the atmosphere until it expands and rises like a balloon filled with fire. On the night side, the same air cools and contracts, creating a pressure differential that drives winds with the fury of a planetary-scale jet engine. But it's not just wind that makes this world a nightmare. It rains glass. Literally. The silicate particles that give the planet its beautiful blue color condense in the cooler regions of the atmosphere and fall as precipitation. Imagine raindrops made of molten glass, each one a tiny bullet fired by an atmosphere gone mad. These glass droplets are caught in the screaming winds and hurled horizontally across the planet's surface at hypersonic speeds. This is rain that cuts like razors, driven by winds that move faster than sound itself. The very concept of weather, something so familiar and predictable on Earth, becomes an alien thing of beauty and terror on HD 189733b. There are no umbrellas that could protect you here, no shelter that could withstand the assault of glass moving at hypersonic speeds through air hot enough to melt metal. The atmospheric dynamics create a permanent storm system that makes Jupiter's Great Red Spot look tame by comparison. Computer models suggest that massive cyclones, larger than Earth itself, rage perpetually across the surface, fed by the endless temperature differential between day and night. These are storms that have raged for millions of years, storms that will rage for millions more. In a weather pattern so extreme, it exists nowhere else in our solar system. Scientists studying exoplanet HD 189733b believe that the glass rain might actually form precious gems under the crushing atmospheric pressure. Tiny diamonds and rubies created in the violence of the storm and immediately shredded by winds that turn them into cosmic shrapnel. On HD 189733b, it literally rains jewels. But jewels that would kill you faster than bullets. Could anything survive in this hell of glass and fire? The question haunts us because life, as we have learned from studying our own world, is remarkably persistent, remarkably creative in finding ways to exist in the most unlikely places. From the crushing depths of ocean trenches to the radiation-bathed environment around nuclear reactors, life finds a way. Even in Mars-like deserts and Europa's icy oceans, the possibility of alien life keeps our curiosity alive. But HD 189733b presents challenges that may be insurmountable even for the most extremophile organisms we can imagine. The temperature alone, exceeding 1,000 degrees Celsius, would denature the proteins and destroy the chemical bonds that make life possible. No known biological process can function at such temperatures. Even the most heat-loving bacteria on Earth, those that thrive in volcanic vents, can barely survive above 120 degrees Celsius. The atmospheric pressure would crush any Earth-based organism instantly. The toxic chemistry, with heavy metals and superheated gases, would poison any biological system we can conceive. And then there's the glass rain, the hypersonic winds, and the intense radiation from the nearby star. Each factor alone would be lethal. Together, they create an environment so hostile that it defies not just life as we know it, but life as we can imagine it in any alien form. Yet the universe has surprised us before. Perhaps in the upper atmosphere, where temperatures might be slightly more moderate, where the crushing pressure lessens, and where radiation is filtered by altitude, there could exist something we haven't thought of. Perhaps forms of alien life based not on carbon and water, but on silicon, methane, or exotic chemistry that thrives in conditions that would annihilate us. The idea of floating life forms, similar to some hypothetical life in the clouds of Venus, continues to intrigue astrobiologists. Or perhaps the lesson of HD 189733b is that some worlds are simply too violent for life, too extreme even for nature's remarkable creativity. Perhaps this is a dead world, a world that has never known the touch of biology, that exists as pure physics and chemistry, without the organizing principle of life to give it meaning. In ancient mythology, glass was associated with prophecy and vision, an omen, a way to glimpse the unseen. It feels almost intentional then that HD 189733b, a world of swirling glass storms, serves as a mirror, revealing truths far beyond its atmosphere. In our modern age of climate change and atmospheric instability, HD 189733b serves as a cosmic warning. It shows how quickly a planet can become hostile, how balance can vanish in a breath of stellar radiation. It reminds us that planets like Earth are rare not just in biology, but in long-term planetary stability and climate resilience. This makes every NASA exoplanet discovery a reminder of how fragile planetary habitability truly is. As we stand at the threshold of becoming a spacefaring civilization, as we prepare to send robotic explorers to the nearest stars and perhaps one day follow them ourselves, worlds like HD 189733b challenge and inspire us. They are not just distant objects, they are tests, proofs that nature is more creative, more dangerous, and more awe-inspiring than we imagined. In searching for life beyond Earth, we must also study where life cannot exist. These dead exoplanets, these planets of glass storms, supersonic winds, tidal locking, and extreme radiation, show us where the limits lie and how miraculous our own home truly is. HD 189733b is not an Earth twin. It is a shadow version, a distorted reflection of what could have been. A blue planet, without life, without mercy. A planet that shares our hue, but not our hope. And yet it teaches us. In its violence, we see our own fragility. In its beauty, we recognize our good fortune. In its impossibility, we find inspiration. The glass storm planet spins on, locked in its orbit, wrapped in blue and glass and fire. Forever deadly, forever dazzling, forever waiting for us to understand not just what it is, but what it means. If you found this journey through the dark intriguing, like this video and subscribe for more content about the mysteries of our universe. Together, let's keep asking the big questions and reaching for the stars.